start. Thank you very much for participating to today's roundtable discussion on IoT security, innovative technologies and research trends. Given the opportunity that today is the IoT Day, we thought that it would be quite an excellent event to arrange such a discussion among key experts who are the speakers in the panel of today's session. Professor Errol Genebel, who is the project coordinator of SerIoT from IITIS. Dr. John Soldatos, who is a member of the coordination team of the SecureIoT project and represents the EU-IoT project as well from Intrasoft International. And Mr. Andres Vilmos, who is the IoTAC project coordinator from Atos. I will introduce myself. My name is Sofia Tsekeridou. I'm also at Intrasoft International and will be moderating this panel discussion today. So the aim is actually initially to present the participating projects. Professor Gelembe will present the SerIoT project, while Dr. Soldatos the SecureIoT and EU-IoT projects, and Mr. Vilmos the IoTAC project. All projects deal with the IoT and security domains, and you will hear about innovations that have been produced in the already mature SerIoT and SecureIoT projects, and the lessons learned that will feed also the discussion into what needs to be further investigated within the EU-IoT and IoTAC projects. A panel discussion will follow that I will moderate. As some few words about the logistics. We aim to record this session, so please, if anyone has any objection to that, kindly please state it in the chat. Your questions, of course, are very welcome. Kindly post them in the Q&A chat box. I will go through your questions during the panel discussion or after its presentation, if there are any, and post them to the panelists. And now it is time, before we start with the presentations and the key speeches for our first poll, to get to know our audience. So I will kindly ask Anna, okay, thank you. If you could please vote from which area and what expertise, from which area you come or what expertise you have. It will be of great value and importance for us to evaluate what the audience already expertise and know-how is, or from which domain they come from. So let us give a couple of minutes for the audience to vote. Okay, thank you very much. Now I will stop sharing, and I would like to give the floor to Professor Genebel for presenting the SerIoT project.
Thank you very much, Sofia. I will try to share my screen.
Okay, while doing so, let me stop sharing.
Yeah.
While doing so, let me summarize also the results. So I see that a significant number of technology providers in the IoT applications field are present, as well as researchers. A few from the IoT security field, technology providers, but quite a significant number of researchers, which is very, very nice to hear. So we expect also your fruitful questions to our panelists. Thank you very much. And the floor is yours, Professor Gelembe.
Thank you very much, Sofia. I'm Errol Gelembe. I'm the member of the team that's coordinating the IITIS project, which is coordinated by the Institute of Theoretical and Applied Informatics of the Polish Academy of Sciences. And my name is at the bottom, Errol Gelembe. I'm heavily involved. Just a couple of words about my background. I am an expert. If anyone is an expert of anything, you can say you're an expert of something. I'm an expert about the performance of computer systems and networks. That is my area of expertise. And currently, I'm working on the performance of IoT systems from the point of view of their security, but not only, because in our research projects, we also look at issues, for instance, such as delay, response times. We also look at issues of energy consumption of the IoT. So we look at things, of course, in a more holistic manner than just the IoT's security. So the SerIoT project is actually coming towards its end. Therefore, it's a good time to take stock and talk a little bit about its innovations. What is it contributing to the subject? What are the issues it tried to look at, and where was it successful in getting some results and innovations and so on? So this is the framework of my presentation. The project duration is 40 months because we had a 4-month extension due to the COVID pandemic, because a lot of our work has to be actually implemented in test beds which do not belong to the developer. For instance, IITIS has developed some technologies which are implemented and installed in Berlin at Deutsche Telekom. So this situation created some unexpected issues with COVID when people couldn't travel and actually go and install things. So everything was a bit longer with respect to installation. That's why we got this extension. And the project is coming to an end in April. It was a €5 million project approximately. And we have partners from 7 European countries, plus the UK. The UK was, of course, within the EU when we started. It is not now. So we have 7 EU plus the UK, and we also have the JRC, the Joint Research Center of the European Communities, where the lab is located in Italy and the headquarters is in Brussels. And the countries are Austria, Belgium, Cyprus, Germany, Greece, Poland, Spain, and the UK. Now, this project didn't come out of the blue. It didn't just, arise out of nothing. It's linked to several other projects in the past. And some ideas from these projects have continued into this one, including FP7 Cascadas, Panacea, Nemesis. I was coordinator of Nemesis as well as SerIoT, Ghost, and Confido. And it's interesting that Nemesis was about mobile system security, Ghost was about IoT, security for the homes, Confido was about security of health systems. So all of these are, Cascadas was about autonomic communication. So all of these, as was Panacea. So all of these were successful projects which led progressively into this one. And I was involved in all of these projects. What are the technologies we are looking at? Okay, what do we try to do? First of all, we try to look at threats, but looking at them, it's not like looking at papers about threats, but looking at threats that are occurring in a real system. Okay? And we want to do, first of all, smart attack detection. We also want to, once we have detected attacks, we want to be able to deflect them, move them somewhere else so that they don't bother the system's normal operations. And we want to mitigate. And we mitigate by various means, one of them being we reorganize the communications in the system so that the parts which are the most sensitive will not be affected by the attack. And then we try to, of course, move the attack to honeypots and so on, and we're creating a system. In fact, it's a system view of the whole issue of attack detection and mitigation for the IoT. These are the primary objectives. Okay. However, there were secondary objectives as well, which were related to quality of service, as well as to energy consumption. So we have work on quality of service and energy consumption of IoT systems. With respect to, for instance, quality of service in IoT systems, we discovered something which we hadn't expected at the beginning. And this was that because we are using software-defined networks as a practical way to implement some of these things, software-defined networks are changing the status of the network, of the IoT system, constantly. By constantly, I mean every so many hundreds of milliseconds or every so many so few seconds, the system's behavior is being changed. As a result, the system is never in steady state. It's always changing. Okay? So while you've changed something, then the rest is catching up and you have transients. So we hadn't expected this. And so this was an interesting discovery that required some further research. Now, I've just talked about research and innovation. However, the quality of things is only tested when they're put in a real operating environment. Therefore, our project has several use cases, which are not just use cases, they're actual operating systems, operating environments. One of them is in manufacturing robotics for Deutsche Telekom. They're supporting IoT systems for industry 4.0, I mean, basically manufacturing systems. Another one is related to urban public transport, and this is at OASA, a bus company in Thessaloniki and Athens and various places, and this is run by our partner CERT and ITI. Supply chains for transportation of perishable goods, including medicines. When you carry, COVID vaccine in a truck, you have to worry about the conditions of the truck if you want your COVID vaccine to be usable at the exit point. Okay, so this specific thing of supply chain for fresh and perishable goods is a specific application that we have looked at in detail in this project. Then smart vehicles and vehicle management, where you have to avoid accidents, at least, even when you have an attack, an IoT attack and cyber attack, you should avoid bad consequences like cars banging into each other. And urban traffic management, which is a bit different from that, which is less, if you wish, urgent, but you don't want to send everyone. You have an attack and you don't want to send everyone into kind of a long queue waiting in front of a red light. So you want to dispatch your traffic adaptively so that even when there is a cyber attack, people can get to more or less in good time to where they need to get. So we have these real applications. And then we have some other aspects that we've looked at. For instance, we've looked at the way technology is going with the fog to support IoT devices. We've looked at blockchain, although it wasn't a specific concern of the project. We looked at how to use blockchain in this context and so on. So I've given you kind of a broad perspective, and then I'll try to be a bit more specific. And of course, I'll also try not to talk too much, which is very bad because we don't have too much time. So the approach, okay, so we have basically the little picture you see on the right-hand side. So we have various kinds of IoT devices, and they're connected and they have to be examined with mobile devices. They need to look at them as well. And we have to have some observation of our system. So we end up having a network, okay? A network which is controlling a given IoT. You can think of this, some kind of application is being controlled by the network. And we find this scheme, this picture, in all of the applications we have looked at, all the specific applications. They always end up having something like that. And this is run by a controller. And who's the controller? And the controller is just an SDN controller. Why did we choose SDN? It's because it's become an industry standard. So we're not going to force some kind of crazy new idea about how to implement these things. We're going to say, look, currently industry thinks that SDN is good. Great. We use that to do the control of the system, okay? And what we try to achieve, we try to achieve security, quality of service, energy efficiency as the system is being run. And how do we do it? It's not just the SDN controller by itself, because if you use a standard SDN controller, it's just using shortest path algorithms to connect a source to a destination. So by itself, it doesn't offer the possibility of doing the required control. We introduce an ongoing reinforcement learning control algorithm. Okay, so that's where machine learning comes into the picture. At least it's one of the places where machine learning comes into the picture. The reinforcement learning algorithm is constantly updating the paths so that the requirements of the IoT system are preserved as well as possible, including in the presence of attacks. This is the general architecture of the system. I won't dwell on it a lot, but it's the way it's designed. It's an overview of, if you wish, of the whole software architecture of the system, including the network in the middle. I will go over that quite rapidly. And now I will talk a little bit about practice, okay? How put these into practice. Now, let's take flexible manufacturing. Incidentally, we have a very good website. And on the website, you have a lot of demos. Okay, so for instance, all of our use cases have demos on the website. There's even background music, so you absolutely love it. It's kind of a relaxing, if you want to waste a relaxing half hour looking at a demo with music in the background, you can go there on the SerIoT. It's directly on the SerIoT website. So flexible manufacturing, what is happening? There's a robot sitting there. Okay, and this robot is supposed to do something on the factory floor. Now, the robot that DT has used is a small one. But if you look at factory floors, some of them are quite big. And if they knock you on the head, it's not nice at all. It can give you some kind of unpleasant experience when you try to sleep later, okay? So these things, therefore, if there is an attack, you must do two things in a certain sense. You must reorganize the communications for the attack to go away, but at the same time, you must freeze the robot so that it doesn't start doing things under the effect of the attack. So it's kind of a complex situation, and this is detailed in the use case. So the use case is actually implemented with our software developed, for instance, at IITIS in Poland, which is ported and installed on an actual physical network plus robot in Berlin. Okay, so this is the way, and you'll be able to see this if you look at our website. You'll see the demo with the music and everything. Okay, and then, for instance, if you look at the case of the SerIoT application to public transport, you're talking about cameras on buses. Okay, the cameras on buses have a circuit which can be visualized by the bus driver, but which is independent and reports back to the bus depot. Okay, so all of that is included in this demo and in this actual use case. And what you see is, an attack which tries to either block or present false information to the output of the camera. And so it's a sophisticated attack. It's not just denial of service, it's actually introducing some information which may be false. Okay, and then you have to detect the attack at using AI techniques, but at the same time, you have to warn the bus driver, you have to warn the system administrator so that they're aware that this is happening, okay? And then you must try to establish alternative paths for the communication from the video camera till the end users, which include, of course, system administrators. So all of that is actually developed. So I won't go through this in step by step for all of them. It would just be too long. But let me just give you an idea of the front ends, because I've talked about the core. I haven't talked about the front end. The front end is to develop attack detection techniques so that, and this is work that was done with the Technical University of Athens, we work together on this. And the idea is, first of all, that all attacks cannot be known in advance. Okay, so rather than try to program your attack detector for all possible kind of attacks, we program it, or if you wish, we teach it. It's a machine learning based thing, so we teach it to know itself very well, know what normal things are, and act by exception when what you see coming in is not normal. Okay, so this is the approach, and then this provides a way to detect for a very simple kind of denial of service attack, which is called a SYN attack. And SYN attacks are very easy to set up. Basically, the attacker opens a connection with you. You say, okay, great, kind of join me and we're going to talk, and then doesn't do anything. And then opens another connection. So you're kind of all the time spinning off, wasting your time, handling open connections which never close. So you need to detect this and then ignore, of course, ignore these requests of open connections from given IP ports and say, look, this is nonsense. So the attack detection part is part of the work, and this includes work also done by our friends in Thessaloniki at CERT, who have looked at integrating multiple nodes of a network to together decide whether there's an attack is happening. The previous thing I talked about is where you're looking at one attack and you're working on it. Here, what they're doing is saying, oh, there are things happening at various places, and we're going to use network graph neural networks, interconnected neural networks, to decide together what the problems are and what is happening, and then to report, of course, this to higher authority. And these little curves here show you transient effects and so on, and how time what kind of events are happening in the system and how long it takes to repair them and so on and so forth. So those kinds of things. So I've already been rather long. There are lots of interesting aspects that exist in our set of innovations, and each thing is that each innovation finds its place in one of the use cases. So each use case is kind of taking one innovation from here, one innovation from there, and so on, and integrating them into the particular use case to show that these are working as a system, that they're working together. Okay, so there was also the FOD computing aspect that was developed by our colleagues at University of Essex, with very interesting issues of how the fog should be managed to face these kinds of things. Now, one of the questions is, of course, standardization. Okay, so as we get there, I'd like to say that there have been some specific successes in the course of the project, in particular with our colleagues at Hopu, who are basically an IoT company. So they've moved some things into the IEEE standards. However, it took us a long time to get ETSI to look at our project as a whole. But we succeeded not more recently than, or when was it? About a week ago. We finally got a yes from ETSI. So they will be looking at this project carefully. And our colleagues at JRC were very helpful. So they will be looking at our project carefully, step by step. What are the different aspects that we have introduced, and which of these can be subject to standards. So there's an ETSI also opening, if you wish. Let me just finish, because I think I've talked too much. Let me just finish. We've had a lot of good refereed publications, including in some of the absolutely top IEEE journals, including the proceedings of the IEEE, in addition to the implementation, and in addition to the fact that these implementations are actually demonstrated in some real things. So here you see basically that we think that a lot of the technology platforms that we have developed will continue being demonstrated for at least 2 years. So we look forward to more interaction with industry and so on beyond the end of the project. Thank you very much, Sophia, and sorry for having been a bit longer than I should have been.
Thank you very much, Professor Galembo. It has been very, very interesting, and indeed the achievement with respect to standardization that also leads the way to certification as well, because standardization is part implicitly also of certification is really very important, since this is ongoing work happening also at ENISA to provide cybersecurity certification guidelines. I will not take any questions now because we are already advanced in time. I would prefer that we proceed to our next speaker, Dr. Soldatos, to present the SecureIoT and Eu-IoT projects. And then, if time permits, we can have a couple of questions. Otherwise, we will leave them for the end of the presentations. Dr. Soldatos, the floor is yours.
Thank you very much, Sophia.
Professor Galembo, if you could stop screening, stop sharing the screen, please.
I'm trying to find out how I can get out. I can stop sharing my screen, but I can't do that. Perhaps I cannot do that. I don't know. I don't see anything where I can click.
Usually it's on the top. It says stop sharing with red highlights.
Unfortunately, I don't see that. Because
it's a green bar on the top. Green bar on the top.
I don't have that. I don't have that.
I'm not sure I can do that.
Andras, can you kick me out?
I can try, but I'm not sure. Okay, let's try it. All right, yeah, okay.
Yes. Now we see your screen or your video, Andres.
I'm out.
John, can you share? Yes.
Yes, I hope you can start seeing my screen, and now
yes.
in full mode, right?
Yes. Yes. Now it's okay.
Okay. Thank you very much for the opportunity to honor the IoT Day. Let's not forget that today is the IoT Day. Many people in the IoT community do not know about this day, but it happens every year, one day. And I'll talk about the main outcomes, the main results, and the philosophy behind the SecureIoT project. That was a project, Horizon 2020 project, EC funded, that ran for 3 years, starting to 2018 through 2020. And actually the motivation for this project was another very important day in IoT history. Actually, I think it was the 16th of October 2016, when the first very large-scale distributed denial of service attack happened, exploiting IoT devices. It's probably the largest attack that ever happened in relation to IoT infrastructures and services. October 2016, associated with the Mirai malware, and actually on that day, even major service providers and websites like Twitter, Amazon went down because of a distributed denial of service attack orchestrated by compromising IoT devices. And this was a defining moment because it showed how important is IoT security and the specific challenges of IoT security, specific challenges that are introduced by the proliferation of IoT devices, and then them having also access to the public internet and so on. So yeah, I think this was a game changer, and also another motivation for our project was the rise of smart objects. So IoT nowadays is not just about passive devices like sensors or meters and so on, but also active objects like automated guided vehicles, autonomous cars, connected cars, maybe fleets of drones. And this means that once upon a time, security and IoT security were about financial loss. You know, something happened and some people had to lose some millions of euros or dollars and so on. This is not any longer the case, because all these things that I was talking about can have life-threatening implications, right? Like autonomous cars or connected cars. The stakes are human lives, not just money. So that was, you know, our motivation. So we wanted to provide a solution that works for different granularities of IoT systems and different types of IoT systems, and even, you know, being able to protect systems that span different IoT platforms in the supply chain, in the value chain, which you know, where security information is different. And we're advocated for this data-driven security approach. We've seen earlier in the previous presentation of SerIoT that you know, machine learning and AI can be one of the solutions to the problem. So we've seen a reinforcement learning approach, and this is partly part of the SecureIoT approach. So this is, you know, an overview of the architecture that we actually not only specified but implemented every module. This is actually inspired by standard-based architectures like Industrial Internet Consortium's security framework, so IISF. The idea is that the system you see, maybe, you know, with all these, you know, quite involved boxes, these interfaces to different IoT systems, smart objects, cyber physical production systems, entire IoT platforms, collects information from them and then analyzes this information to detect anomalies, to detect abnormalities in security behaviors, and also to define through the right policies mitigation actions. So this is at a high level what this architecture is about. So you can see that we manage a number of probes that interface to different platforms, to different types of IoT systems, collect their data, then these data are consolidated, and we are able to analyze it with a set of, you know, security templates. So that's, you know, typically security analytics, including machine learning and deep learning algorithms that enable the identification of abnormalities. And then using this and the security knowledge base, I'll talk about it in a while, we can offer a set of services like, for example, IoT risk assessments on IoT assets, but also more than risk assessment services like compliance auditing services and some service for developer support. So yeah, this is you know, what we have in our template. So we've got more classical anomaly detection and rules, but we have also machine learning and AI, like, you know, process mining, so mining logs of different events and trying to fetch abnormalities, or even applying deep learning on smart objects like connected cars and trying to see whether they deviate from normal behavior and what you have to do when this happens. And also in cases where you don't have enough labeled data and supervised learning approaches, just to spot, you know, what deviates from normal conditions. We've got also a marketplace of different solutions, and I invite you to join it in marketplace.securiot.eu. You can register there, and then you can have access to a rich set of solutions ranging from probes for collecting security data, security data sets, to actual IoT security systems like IoT risk management engines and so on. So a little bit more about our services. So yeah, the risk assessment and mitigation service, that's a classical risk assessment service. Risk assessment, as we all know, in security is probably one of the most important processes. Now, what we are doing here is we took a conventional risk assessment engine and we augmented it with data-driven insights from the AI and the machine learning algorithms. And then we gave also a tool that you can browse the different assets view the threats, the vulnerabilities, the criticalities, and also possible mitigation actions. Another thing is the compliance auditing, and the scope of our compliance auditing in a SecureIoT was defined by a security policies database repository. So within a repository, we could formally specify a number of different security policies about IoT systems, for example, specific IoT devices. And then our system, our security analytics, were checking whether this device complied to the checklist of the policies. And this is very useful before deploying a device, but also at runtime to see if there is something, some deviation from the expected behavior and from the regulatory compliant or the legally proper behavior. Our third service was something, for security developers, for IoT developers, to help them, create more secure programs. So the idea was very simple from the developer's perspective. We gave to security developers some annotations that they could use inside their code, and then this would map to security policies that an operator defined in the SecureIoT platform. In the end, once the code was compiled and deployed, the user would see the security behavior, the intended security behavior specified by the developer being actually enforced. And one of our assets, as I said, was the SecureIoT knowledge base, a knowledge base for IoT vulnerabilities and threats. I want to take a few seconds to talk about the importance about IoT security knowledge bases. Of course, as Errol said before, we shouldn't work only with what we know, right? Because there are always new attacks and asymmetric attacks, and we can't say that, okay, it will occur to us what has happened in the past. So this is very true and very correct, what Errol said in the previous presentation. But on the other hand, if something known is happened to us, so something which is known in the community, it is very important to be able to decode it very fast and say, okay, this is a Mirai attack, this is a WannaCry attack. So that's why it is very important to accumulate the security knowledge in a knowledge base. And this is what we did in SecureIoT. So we consolidated a lot of cybersecurity knowledge bases, not only IoT related, and we included also, I think, a number of IoT security vulnerabilities, including some vulnerabilities from the specific domains where we applied these technologies, and we consolidated the knowledge to the knowledge base. Now, there is a clear value proposition there, right? If you see an abnormal pattern, you can ask your knowledge base, what is happening there, right? Is this something known? And then you get a response. And if you get a response, then it's easier to understand what you have to do, because the community develops responses for known threats and attacks. So that was the SecureIoT knowledge base, which is one of our great assets. And of course, we develop on it graph databases and graph analytics so that you can do inference within the knowledge of the database. Now, we provided these services also as a SecAS, security as a service model. This is a very useful business model and delivery model, especially for small, medium businesses, small, medium enterprises that wouldn't afford to have an on-prem deployment of the entire platform, but still they might be willing to have a service that, they just give some data about the device to a trusted provider, and then the provider provides the risk assessment. So in a sense, they can just, give some data and pay for what they use. So we gave this security as a service approach, this cloud-based delivery of the SecureIoT platform, and we applied this in 3 different domains, each one comprising, smart objects, and each one having, very topical relevance and also very high societal impact, I would say. So it was the Industry 4.0 case in a multi-vendor environment with different automation platforms in a supply chain setting, socially assistive robots, actually securing robots that they serve children and other healthcare scenarios, but primarily children with autism, and also connected cars, and with an outlook towards autonomous driving. So we did a real test in a connected driving sandbox in one of our partners in Spain and the UK. So actual cars, driving and being able to secure them. And yeah, we were able, sometimes to record and to quantify some benefits, right? So, investing in security, that's always a problem we have with IoT security, but with security in general. Sometimes managers, treat this as a defensive investment because, they usually say, okay, if I put some money, I want to get an ROI, a return on investment. Now you put money just to defend yourself. But we try to explain and to quantify the return on investment here, which is, if you are obliged to do, for example, a large recall of cars, this has happened in the past with several companies, because of some hacking of the software, you can understand the enormous economic impact and brand damage that this can have to an automotive vendor. And of course, we quantified some things that we managed to do, right? Like recording a number of threads about the QT robot, the socially assistive robot in the knowledge base, and being able to provide a quite fast detection by working on an edge system. Of course, in this project, we didn't care so much about the underlying network, which was one aspect quite evident in SerIoT, if you recall the previous presentation. Well, you can read about SerIoT and about SecureIoT in this book, which is open access. It's going quite well. We have already 15,000 downloads, and it's having good acceptance by the community. But if you haven't downloaded this book yet, you can do that, for free. And this is something that Errol, myself, and other colleagues put to the community, right, freely last year. And that was, Sophia, the SecureIoT presentation. And I would like, if it's okay with you, to go straight discussing, the Eu-IoT project in a couple of minutes.
Yes, thank you very much, John. Again, I will leave the questions after the end. Just kindly remark, it's a very interesting presentation. Of course, both projects have been mature enough to provide quite a lot of outcomes and insights and research results. Of course, a comment with respect to the cost that you mentioned and the economical impact with respect to cybersecurity attack and incident and what this would mean to a company. Of course, this is quite very significant, and in line with that, cyber insurance is also another measure to take within the companies, especially SMEs, in order to share the cost as well as not invest too high budget for their security measures. So please proceed to the Eu-IoT presentation. At the audience, kindly please retain your questions after the end of the presentations. Thank you.
Thank you, Sophia. I think you are very right. I think cyber insurance is a field that is emerging, right? And we see, more and more offerings there. And this shows, also the business relevance of the thing. So I'm going to very quickly talk about Eu-IoT project. It's not a security project. It's a rather new project that is aimed at doing, coordination of the most recent Internet of Things project of the European Commission, and we hope that IoTAC project that will will be presented later, will be happy to join also our portfolio of projects and do some coordinated efforts. So it's actually Intrasoft is a partner. We were the coordinators of SecureIoT. Here we are a partner, and Eu-IoT is coordinated by Martel Innovate, Ms. Monique Callisti. We started 1st of October 2020. We are 5 partners in total. Well, the main objective, is to coordinate the entire portfolio of activities to set strategic agendas, to amplify the impact of the projects, but also to provide support and coaching to the project throughout their lifetime through a number of activities. I'll talk more, about the security. Just to say that as per our coordination role, we have a very close bonding with other initiatives that have a very huge impact on the EU ecosystem, like Alliance for IoT Innovation, Fireware, IoT Forum, Gaia-X, and so on. So, we span the IoT space beyond security, but, it's our role, to act as an intermediary between research projects and all these bodies. And the key area of focus is edge computing. So I think this is also at the very top of the strategic agenda of the European Commission. So IoT is moving at the edge, sometimes at the far edge. It means, at the devices, embedded machine learning, AI, IoT. So this is one of the main strategic topics where we are coordinating project efforts. And, in edge computing nowadays, it's not a single thing. We have many different ways to do edge computing, and each one of them, in my opinion, is offering some very good security or privacy value proposition. So things like federated machine learning, or running things directly on the devices. This gives you some security and some privacy in some respects. New cryptographic approaches, homographic encryption to be run on distributed paradigms. Also, blockchain is sometimes used at the edge. But of course, when we do this and when we do AI at the edge, we have also new security challenges. And I think that IoTAC is probably addressing some of them. Also, the AI is introducing new challenges, as you know. So AI is always a good thing, but there are also, cyber attacks that are aiming at hacking AI systems, like poisoning and evasion attacks. So new opportunities, new challenges. Eu-IoT is doing coordination in this respect. So we will be publishing soon a white paper on the different edge paradigms and how they impact different research lines. Also, we will be releasing soon an IoT open source white paper with a good benchmarking of the most prominent IoT, or the most prominent 100 open source IoT projects. This is a preview that you see here. We hope to make it available in the next month and provide it freely available to the community. Of course, there is a rich set of other activities, like training, certification, success stories, documentation, and we really want to have other projects and IoTAC with us in this journey. So thank you, Sophia, and apologies if I was a little bit over time, but they were just 2 projects. So I would say stay tuned in Eu-IoT because it's a new project, so you can see it around.
Yes, thank you very much, John. Indeed, very, very interesting. We would welcome the participation, of course, in Eu-IoT activities, and looking forward to the white papers as well as the clustering and all opportunities that can emerge through the synergies of the project. Now we'll give the floor, since the time is already near 1 CT, to Mr. Vilmos to present the IoTAC project that has been actually the initiating project for this roundtable discussion. And I forgot to mention that all present panelists are also partners of the IoTAC project. Thank you. Andres, the floor is yours.
Sorry. Good afternoon. In my presentation, I will introduce the IoTAC project, which just started about half a year ago. It runs for 36 months, and it received a contribution of 5 million euro from the Commission. We have a pretty long but descriptive name. It says Security by Design, IoT Development, Certification Framework, and Front-End Access Control. These are all activities which we are covering, and a number of others which are also will introduce. We have I can't move for some reason. Okay, yes. We have a large and strong consortium with large multinational industry leaders, a number of smaller SMEs, and also the academia is represented with universities and research institutions. We submitted our proposal for the call SUICT 2, which was calling for a resilient ICT system. We presented a concept to establish a complete a secure IoT architecture, and it has 3 pillars. Actually, we are focusing on all components of the architecture: hardware, software, and algorithms. We have a security target, which means besides the usual confidentiality, integrity, and availability aspects, we have a strong focus on privacy, data protection, and accountability. And whatever we are doing has to be user-centered, so it has to be measurable, has to be under the control of the user, and last but not least, very important, has to be trusted. We have a complete framework comprising a number of specifications, methodology, and the actual physical architecture. So let's go through all these components one by one. The security baseline is the overall security guide for the project. It provides security specification for the overall work, and it also describes the solutions for the addressed problems. So we started with information collection. We communicated with the IoT service providers. We were asking for description of their operation and what are those assets which need to be protected. Then we also analyzed a number of reference architectures to find out the best practices and also potential weaknesses. These architectures were the OTP way, the 1M2M, the ISO 30141, and Azure. And we also looked at the prevailing standards. What are the qualities and what are the targets which IoT systems need to meet? Based on these findings, we started to identify misuse cases. How can a system be abused? What can go wrong? And right now we are in the process of elaborating the security requirements. When we will have completed this work, we are going to define the concrete security solutions, the methods how to prevent attacks and threats, and we are going to assign KPIs for all these methods and solutions to be able to evaluate our results at the end of the project. The next element of the framework is the security by design methodology. We will have a software security by design platform, and while the security baseline is related to the physical architecture, this platform will assure code level security of the applications we are implementing. The platform comprises 3 modules. a requirement engineering module, which is actually requirement specification, an assessment module, which has two models, an assessment model and the vulnerability prediction model. And it also has a validation component. This validation is based on the aggregation of multiple measurements, and based on the results, the code quality will be defined and a label will be provided. This module should eventually be automated or have at least a semi-automated operation. The next important component of the framework is the validation, the IoTAC validation program. Present EU policy calls for EU-wide standards, also relying on well-accepted existing standards, but avoiding individual and frequently conflicting initiatives. The first step in this direction was the enacting of the EU Cybersecurity Act, and now ENISA takes a leading role in all related activities. A major result in this approach was the publishing of the draft certification scheme for cloud services at the beginning of this year. We expect that one of the next schemes may cover IoT security standards and related certification. We will align, so IoTAC will align its activities with the EU initiative. We will contribute to the new standard with our research results. We will implement testing suites and elaborate audit programs. And in general, we will actually validate our results against these standards or this standard. And in general, we will promote the European activity. Now that we have looked the methodological part of the project, let's look at the physical architecture. The architecture comprises a number of modules. We have an access control system, Honeypot, checkpointing, AI and ML-based attack detection, a runtime monitoring system, and all these going to be combined with a secure gateway. In addition, we are also going to develop SDKs and APIs to assure that integration of our solution into the IoT environments will be simple and painless. So let's walk through these components one by one. Well, we are introducing the front-end access control solution. In general, prevailing access control systems are not really suitable for the IoT environment. They are not well scalable, they are pretty much centralized, and they need too much resources. So with these findings, a new model, the capability-based access control, was introduced a few years ago, which is based on tokens. The token is actually a signed declaration that its holder has specific access right. And at the point of acceptance, no authentication necessary, no access rules needs to be known, just the validity of the signature on the token has to be checked. Now, this solution has a major weakness, or it's a challenge, how to protect this token when it's already issued to the user. And this is where IoTAC comes in. We are integrating a chip card, a secure element on the user side, which will not only protect, but also generate the tokens. Other than that, it's gonna be a normal capability-based access control solution. However, to make the life of the users easier or more user-friendly, we are also implementing a new so-called card farm. This is a large number of cards somewhere in the cloud. so the users don't have to carry their physical cards all the time with them. The next component is Honeypot, which is actually, it's a bail. It's luring the attacker to an unsafe visible site, while the valuable real one remains hidden and protected. Now, this is not the other function of the Honeypot. This is obviously a real-time function. The other is to analyze the attacks and to elaborate the necessary countermeasures. A similar solution is checkpointing. Actually, checkpointing may be known already from the PC world. Whenever there is some error in the system, it can be restarted from a specific status somewhere back in the past when the system was still functioning properly. So this past point is the checkpoint. But this is a new concept. This is a new concept in IoT. So when we are identifying that there is an attack going on against the system, we are interrupting the operation, and the whole operation can be restarted from an earlier point when the system was not compromised yet. Sorry, something happened with my presentation. Yes, so far I pretty much knew what I was talking about, but I guess at this point it's better if I ask Errol to say some word about this AI-based attack detection.
With pleasure. As we all know, we're not allowed to actually look at the content of packets which are coming. If we could and interpret the software that's in the packets, we could more readily know about attacks. So we have to rely on external properties of packet streams to do our attack detection. In particular, John, in his presentation, Dr. John Soldatos, in his presentation, he talked about a very bad sequence of attacks that started in 2016. And there were several of them. And for those attacks, it was identified, I mean, what they are doing is they're actually compromising the IoT nodes and turning them into attackers themselves. So it's worse than just attacking someone. It is taking someone over and using that one to attack the others. And this is due to the fact that a lot of IoT devices are deployed when they come from the factory without appropriate changes in protection, including in passwords and things of that nature. Since they're such simple devices, they're kind of furnished in mass from the factory, and then they're installed in mass in the system, and then the compromises are easier. So we actually looked at exactly the class of attacks. In this work, we looked at exactly the class of attacks that John indicated, which are of these kinds, where they compromise IoT devices by taking them over and turning them into attackers. And we analyzed, and this is work within IoTAC, and we analyzed the statistical properties of these packets that are taking people over. And it turns out that they have specific characteristics with regard to length and with regard to inter-packet times. So we use these characteristics, okay, to distinguish between normal packets and abnormal packets, and we train a deep learning neural network using these characteristics from data that John Soldatos in his project and others like him have collected. So we use that data that was collected in previous EU projects in order to train the attack detector, and then we were able to test the attack detector similarly on data, obtaining some very good results regarding the performance, very high results regarding the performance of this technique. So what I'm describing is work that we have accomplished in the first few months of this project. Thank you very much.
Thank you, Errol. The next module we have is a runtime monitoring system. This is a system which collects security-related data real time about the operating specifics of the overall system, and it drives analytic algorithm to detect abnormal behavior. The system comprises monitoring probes, assessment algorithm, prepares automated responses, and also provides data on a dashboard for the operators. Now, when we have all these modules implemented and tested, we are going to combine it with a SecureIoT gateway. The gateway itself already has a number of security features like secure booting, secure update, device registration, as well as network monitoring capability. But we think that with the addition of our new modules, its capabilities will be enhanced. And we are also going to validate this assumption against the KPIs which we are defining in the security baseline document. Now, when we are completed with all these exercises, we are going to validate our architecture in 4 industrial environments, in 4 pilots. The one is going to be a smart energy cell, a prosumer operation. It will comprise solar panels, car charging, batteries, and the system will be connected to the grid. And we are going to protect the overall operation. We are going to protect data in the system, and we are going to implement the access control solution to assure that users will have access only to those features to which they are entitled to. The second pilot will be a complex smart home operation. It will have an HVAC system. It will have the usual smart home devices, home appliances, and also smart home applications. And first, we are going to measure the code, review the codes with the SSD platform. And we are also going to implement the gateway, introduce the gateway, and assure protection of the overall system. The third pilot will be an autonomous driving pilot. It will be a platooning use case. This means that we are going to test the merging of a vehicle into a synchronized row of moving cars. And the fourth pilot will be a drone operation, where we are going to protect the maneuvering of the drones, as well as the data which is collected by the drones. So in summary, this is our complex architecture concept. And if you have any questions, you can raise it in the following Q&A session. And thank you for your attention.
Many thanks for this presentation, Mr. Vilmos. I would like to point out also that, of course, in the implementation of the IoTAC system, we do follow a DevSecOps approach so that we take security from early stages of the design and development process. And of course, a security by design architecture specification that is also led by our colleagues in Thessaloniki, SerIoT. So this is actually indeed a core security project that addresses security from all dimensions and viewpoints. Now I would like to open the floor to the audience as well to ask questions. While this is done, and I can actually also pose them to the panelists, I would like to start with a few questions. One important aspect that we mentioned since the start of the panel discussion, the roundtable discussion, is how do you consider that the more mature projects actually could feed their results into the just initiating projects? How can they interact and leverage each other's results? So I would like first to ask Professor Gelempe and then Dr. Solvatos.
Would you mind repeating your question?
So how do you consider that the projects could interact and leverage results between each other, especially the ones that are more mature and have already produced results to the ones that are in their initial phase?
I must admit, I didn't understand your question.
Okay, so we have been actually hearing the 4 different projects today. 2 of them, SerIoT and SecureIoT, are quite advanced projects that have delivered quite significant results, technological results, research results. Also, you mentioned standardization activities already in place. These, I believe, have a lot to feed into the projects that are in their initial phase currently. So I understand that it would benefit all projects to interact and exchange know-how and experiences. And what is usually more beneficial is for the mature ones to fit in to the initiating ones. So how do you see this can happen?
I think we are doing it in a certain sense, and for instance, the example I gave about what we do in IoTAC is directly derived from what John mentioned in his presentation concerning a project that had finished. So this connection is happening. However, I think that the world does not change so fast, even when we have information technology. I think that the continuity is assured by people. Having people in one project move to another one is one way of moving know-how. And the fact, for instance, we met with John a year ago in Brussels. You remember, John? Where we decided about the article, or you proposed the article, and we did it and published it together. So these things, which are based on human interaction, to me, remain fundamental. We can't expect just to put things in a repository and then someone else is going to pick it out of the repository and do something else. People need to meet, interact, and talk. And they have to be part of similar projects, or they must be part of projects together. And this is the way we do it. And that's the way we actually do it. This sounds very kind of non-original, what I'm saying. But I think that's actually how it happens.
I agree, actually. It's always human connections and human interactions to share know-how and experience, of course, and this is the case here. And also opportunities to be given to continue the research in the domains. So it's not be restricted by funding, ending within a project. It has to further develop because this is how actually we innovate and we think and brainstorm and produce new results. So John, can you please also elaborate?
Yeah, just quickly, I think Errol, opted for being, pragmatic and not fancy, which is okay. But yeah, I mean, although this is, of course, it's true because it's actually, especially in the academic domain, right, and in the research area, there are established mechanisms. Of course, people, and principal investigators, they are assuring the continuity, and also we have contributions like Errol has having, great articles in IEEE transactions and so on, which, diffuse the knowledge of the community. On the other hand, in my opinion, it's always good, the project, and I think we try to do this, with the previous project, and I think it's a good idea for IoTAC, since these are based, on public funding, or to a large extent on public funding, if there are the innovation actions. it's always good to produce things that can be contributed and shared to the community. So, open access publications is one means that we have used. Data sets are always welcome. Of course, there are already, open data sets, but having more data to work with in the security, especially nowadays that we have, AI booming, it's always a good thing. And also whatever other assets we can share, right? Like systems and so on. So, there is an ecosystem, GitHub, open access ecosystem, open data repositories, including some repositories.
That's why I tend to insist so much on porting, having something developed in one partner, say a research partner, being actually ported into an industry environment. We have done this with SerIoT, with a lot of things ported, for instance, to Deutsche Telekom.
Yes.
In a very informal manner, we install them there, and they're supporting them and they're operating them. And this is also a way to transfer know-how from one to the other. So open data is very important, of course. Open source software is a bit difficult. We can port software to someone else, but if you say, I'm putting this publicly, it means that I'm willing to support it publicly. Which means that if someone has a problem, I'm willing to help them publicly. And that requires a lot of resources that people underestimate.
Yes, it's not easy to use somebody else's open source code, right? I mean, it can be more difficult than developing the project from scratch sometimes. So exactly. Yeah, I mean, exactly. It's not how it looks or not. Just a final remark on this question, Sophia, because we are in the same company and we know we have our commercial interests and our commercial solutions as well, but we always try in the projects, right, that we are involved, because this is public funding, we try also to produce open assets for the community. So I think this is a good mindset. And I agree with Errol, it's not automatic, it's not something that, okay, I give you some open source code, but I think it's a good mindset, a mindset of sharing and collaboration in the community, and especially projects that get public funding should go this way, in my opinion.
Thank you. Thank you very much, John and Errol. Just a comment from my side. Indeed, sharing is vital. Data sharing, especially for security, cybersecurity domains, related data is crucial and not that redundant, I would say. People are not sharing such data, so this is something that the community is striving to get access to, real world actual data, because they are quite sensitive, you mentioned. And also there are some good examples of open source software, like for example MISP, the malware information sharing platform that quite significant community members are using, security experts. I would also like to ask Andras if he agrees or has anything to complement on this topic.
Well, I guess in our project we are demonstrating that the results of one project can be continued in another one, because the honeypots, the real-time monitoring system, they are all continuous developments of earlier results, and they are not just continuous developments, but they are tested and validated in different new environments. So the 4 use cases we have where we are going to implement these modules are providing new opportunities. The integration with other security features are also generating new requirements, which are improving these earlier developments. So I guess it's a continuum. Whatever has been done, we don't let it pass. We are building on them, and we are keeping on improving them.
I'd just like to add something to confirm exactly what Andras says. It is very important in technical work, and sometimes we don't realize this. You know, we do something in a paper and we show that something works. It's also based on some specific data. and on some specific expertise that might have existed there. It is extremely important for this work to be confirmed by independent teams. That is, that the same ideas are taken over, used with different data and retried. This is very, very important. So it's not just repetition. It is not repetition. It is taking something in a new context and usually with new data. And not only that, but having, for instance, algorithms implemented by someone different, perhaps even with a different language, perhaps even on top of a different operating system. And this process is, I think personally, extremely important. It's not repetition. It is trying things differently with the same similar ideas. So I'm very much this is also a traditional scientific method, very, very traditional. You know, for instance, a certain biology experiment will be invalidated if someone else does not run the biology experiment in a different laboratory, perhaps with different mice or different cats or whatever. So I think these things are extremely important and should be part of our best practices.
Also in the machine learning, Sophia, as you know, we suffer so much from the biases, right? And sometimes, you know, you're using some data set and you can't understand how many biases exist, right? Historic bias, representation bias, deployment bias, measurement bias. So sometimes it's not intentional, right? People do things to publish papers and so on, but they can be building something which works, you know, in a very narrow domain, and probably it's not an objective system that can be really used in practice. This is a more general problem, not just for IoT security, but I think we suffer in this area as well. And you know, it's also very important for all the AI engineers and machine learning engineers to understand the fundamentals, because sometimes, you know, they just go and use some tools online. It's easier nowadays than anytime before, and whereas this is really difficult because you need, as Earl said, the statistical processing, the statistical understanding of the data, the understanding of the context, so that you are doing some useful AI and not just some AI for the sake of AI.
Indeed, and it's not only the tools or the algorithms used, but it's also the quality of the data and where they originate from, etc. But I think we are in the right direction because now the procedures, the guidelines, even the standardization aspects are aligning together. For example, to capture, let's say, in such a way, this type of data in order to feed AI and machine learning algorithms from different data providers, or even the approach on federated learning, so that data providers are not obliged to share their data, but they can instead use the algorithms and the models locally to be retrained with their data. Okay, we don't have much time now, so I would like to wrap up with a final question. I don't see any question from the audience. So quite a very quick question. Where do you think the IoT security is driving at? What are still the challenges to face? For one, I would see that, okay, the systems are now designed and can handle already existing defined attacks, for example, and vulnerabilities, but more and more are actually discovered or created in the future. So it's always a challenging situation to be able, with what you've developed, to address the unpredicted or the unknown, okay? So this is one thing, one challenge I would imagine, and what we would need to do more work on, how to make more adaptable and customizable such security technologies in order to address even the unknown.
Shall I give a try?
Yes, go ahead.
Yes, please.
So I think what you've said is absolutely true. We are at the beginning of the system, but it's going to become worse before it gets better. Here is why. We have currently, you know, the simple scheme is you have base stations, okay, that are getting better and better, and we're going to have 5G, 6G, 125G, whatever. So the base stations are getting better, and they're offering many more services, okay, games, this, that, and the other. And IoT, for instance, the telephone company will offer the electricity company the possibility to do smart metering, okay? However, to do that, it's not just a matter of putting the IoT sensor, the sensor down into, or kind of connect the sensor to the meter. It's also the issue of storing this and giving this as a service. So you're going to have fog machines behind that. So we're creating a whole kind of additional layer of hardware and software, which is clustered around base stations, and which is going to be taking care of different types of services. I think those systems, in addition to the devices themselves, are going to come under attack. And you know, people will use them even kind of not for an attack, but to mine Bitcoin or whatever. So to clandestinely mine Bitcoin and use the electricity company's energy free of charge, paid by the telecom company, and so on. So I think we're going into a world which is not yet limited. We are still expanding the world. And I think the fog is the next challenge, where we're going to find again all the problems of cybersecurity applied to an area which is completely automated, which is not the user machine, but which is some kind of system which is operating autonomously with the IoT devices. So that's my submission to this question.
Thank you, Errol. John or Andres?
Maybe Andres, you go first.
Okay, I guess as we are seeing the new technologies, 5G, the penetration or the more general use of cloud environments, these will create new challenges. Also, as IoT will penetrate new areas and more and more people will use it for their everyday life, we will have new security issues because probably most of the people are not aware of the threats or don't care about the threats, but this is obviously here. So for me, these are the most relevant security challenges.
Yeah, I don't want to echo what has been said. So I would just like to add that it turns out that, you know, the more technology we develop, like AI, which is trending now because that's, I think, the future of IoT, right? Artificial intelligence on smart connected objects delivering intelligence at the point of action, right? At the point of interest. So doing intelligent things and doing them fast. So this entails fog computing, IoT. So the more, you know, technology we add, the more vulnerabilities and threats we have. Of course, the better tools we have also to address them. So this is something to have in mind. And another thing that I think Andras touched upon it is the human factor. Human factor is going to be very important. So we have to raise awareness and we have to raise, you know, training about security. And the corporate environment, employees should stick with the policies, but even citizens, although I understand that technologies have to deliver a very easy to use and a very transparent security, this is a requirement, it's clear, but on the other hand, it's very important even for citizens to understand the risks, right? To be aware of the risks. So they don't have to be technical people, that's clear, but they need to understand, you know, what is the risk and what a digital society means, right? And this is, you know, for IoT, so, but also for the entire spectrum of cybersecurity. So what it means, you know, having a smart home and devices in my home, what it means, you know, having a single set of credentials and being able to access all the public administration databases or even connect them, you know, with some simple IDs with other organizational databases. So they need to be aware of the risk so that they exhibit responsible behavior, even though vendors have to make this as non-obtrusive as possible and as transparent as possible.
Indeed, John, and you indeed pointed out a very crucial aspect as well, training and awareness, and actually a respective culture that needs to be built is indeed very crucial as well. Now I would like to actually close this roundtable discussion. I would like to ask our panelists if they have any final remark to make. I don't see any question from the audience. So,
I have a quick remark, and that's about energy. We've talked about it very little, but we're heading into a very serious situation with climate change. And you see at the political level, a certain number of people, for instance, the French Senate in the last month produced a report and is drafting a law concerning how information technology can be deployed. And how it must respect or demonstrate that it is effective from a CO2 impact perspective, and also from the whole issues of not just climate change, but also sustainability with respect to rare earths, rare materials, recycling of ICT equipment, and so on. So we're headed there into an area which is going to interact a lot with what we're doing, even though we don't realize it quite yet.
Okay, thank you, Errol. Any other remark or concluding?
Yeah, power efficiency and security would be also some, of the basic requirements when we design an IoT system from now on. So we need to have this requirement, right? What matters the most for the user and the deployer of the system? Is it security, because you can really give strong security, or looser security? Power efficiency, right? So you want a very power efficient system, which means moving things at the edge as much as possible, or you can afford moving data around, running AI on GPUs and TPUs, which is not green friendly at all. It's exciting as an application, but it's the worst thing you can do from a green perspective. So thank you very much to IoTAC project for hosting us today to honor the IoT Day. Thank you, Sophia, for coordinating, and many thanks to the audience for staying. We had a very good stickiness, all the attendees being here till the very end. So thank you very much for the opportunity.
Marton and Andras as well, of course, for taking this initiative and bringing us together.
Thanks for being here with us. Thank you.
Thank you from my side as well, to the panelists as well as to the audience. If you found it quite interesting, we are to reorganize such a roundtable discussion in 6 months to 1 year to present all the follow-up results, as well as what we've discussed today and how it materialized. Thank you very much once again, and have a nice afternoon.
Thank you, Sophia, for taking good care of us.
Bye-bye.
Bye.